Okay, so let's have a look at question 4 for the Leaving Certificate, Higher Level Maths Paper 2, 2018. So we have, here in part A, we have to find all values of x for which cos of 2x is equal to minus root 3 over 2. So we have the cos of 2x, and we know that it's equal to minus the square root of 3 over 2. And we know that x has to be between 0 and 360. So if you take your x and y axis here, we know that the cos of this 2x has to be negative. So where is cos negative? Well, cos is going to be negative in the second quadrant and the third quadrant. They're all positive in the first quadrant, and cos is positive in the fourth quadrant. So our angles can't be here. So let's just draw two angles. We'll draw one here and we'll draw one down here. So I know that one of my angles has to be here, and the other angle will have to be this angle here. So let's have a look and see if we can work out what these angles are. Well, if we take, we just find our reference angle first. So our reference angle is going to be this angle here and this angle here. They're going to be the same angle, because the cos of these alphas here in blue are going to be the same as the cos of these angles in red. So we want to know what angle will give us a cos of, let's say, plus root 3 over 2. Well, you should find that the cos of 30 degrees will give you a value of root 3 over 2. So we know that the cos of 30 degrees is equal to root 3 over 2. So in other words, in blue here, the cos of this acute angle here will be root 3 over 2, and the cos of this angle here will be root 3 over 2, but negative, minus root 3 over 2. So what angle is alpha? Well, alpha we found out is 30 degrees, but that would make this red angle here, we'll call it, let's say theta. We'll call both of these theta and theta. So this theta here, theta 1, let's say, and theta 2, this theta 1 here would be 180 degrees minus 30 degrees. So in other words, our 2x here will be equal to 150 degrees. That's just from here to here, because our reference angle has to be 30 degrees. Now if we take our other angle here, theta 2 here, our alpha here is 30 degrees, that's our reference angle, which would make theta 2 here 180 degrees plus 30 degrees. So that would be 210 degrees. So these are our two x's in our 360 degrees, if you like. But we're not asked to find out what 2x is, we have to find out what x is. So we're going to end up dividing these by 2. So really what we're going to have to do is do a few more of these to get values between 0 and 360. So if we take this angle here, theta 1, if we add 360 to that, that'll bring us right back around to here again. And the cos of that angle then will also be minus root 3 over 2. So we've got to take 150, add 360 degrees to it, that'll give us 510 degrees. Take our 210, this angle here now, this is theta 2, add 360 to that angle, and that'll give us 570 degrees. Keep going, add another 360 to 510, that'll give us, let's see, we have 870 at this stage, 870 degrees. So we can keep going on and on and on here, but let's just work out our x's at this stage and see what happens. So x then, if 2x is equal to all of these angles, we just need to divide each of these by 2. So if we divide 150 degrees by 2, we get 75 degrees. If we divide 210, we get 105 degrees. If we divide this by 2, we get 255 degrees. If we divide this by 2, we get 285 degrees. and if we divide this by 2, then we get 435 degrees. Now we've already gone, remember these are our x's, and it says up here that x needs to be between 0 and 360 degrees. We've just gone beyond 360 degrees here. So really this one here we can discard. Really our x then is going to be 75 degrees, 105 degrees, 255 degrees, and 285 degrees. These are our x values. Okay, so that's it for part A. Let's have a look at part B. We've got the cos of A, we're told, is y over 2. And A is somewhere between 0 and 90. It's an acute angle. We have to write sine 2A in terms of y. Sine 2A in terms of y. Now whenever you see something like this, you should think, you know, your trigonometric identities. This is a double angle formula, or this is a double angle here, so we know that from our tables we can write this a different way. Let's just work out sine of A first. So we know that A here is going to be between 0, A here is going to be between 0 and 90 degrees. So it's an acute angle. So let's say this is 90 degrees here, and we know that the cos of A is y over 2, adjacent over hypotenuse y over 2. So let's just work this value here out. We'll call it x, so that we'll be able to write down the sine of A as well. So our x squared plus our y squared will give us 2 squared, which is 4, by Pythagoras' theorem. So we want to find out what x is. So x squared is equal to 4 minus y squared. Our x here is just the square root of 4 minus y squared. So our x here is just the square root of 4 minus y squared. So now we can write everything in terms of y. So our cos of A is y over 2, and our sine of A now is going to be the opposite, which is square root of 4 minus y squared all over 2. So now we have the sine of A, and we have the cos of A. Okay, so we need to find the sine of 2A. So let's just do that. It says write down the sine of 2A in terms of y. So the sine of 2A, from your tables, if you look up your trigonometric identities in your tables, you'll find that the sine of 2A is equal to 2 sine A cos A. So we know the sine of A. We know the sine of A is the square root of 4 minus y squared over 2. And we've got to multiply that by the cosine of A. Well, the cosine of A is y over 2. Okay, so we've written the sine of 2A in terms of y. Let's just tidy it up a little bit. You can see this is all multiplied on the top, multiplied on the bottom, so this 2 will divide by this 2 here to give us 1, and we end up with y times the square root of 4 minus y squared over 2. And that's it. This is our sine 2A. So this is our answer here. And again, that's it for this question.